In this question, we have a water trough which has a uniform cross section which is semicircular and whose radius is 0.5. Now it's partially filled with water and the water is shaded region here. So the first part of this question, we are required to find an expression for the volume of water in the trough in terms of theta. So a few things first. This water trough has a length of 10 meters. So the length of this water trough is 10 meters. And then another thing is the radius is fixed at 0.5. So in part A, we want to come up with an expression for the volume. Now, since theta is in radians, this is very important. Yeah, since theta is in radians, we can use the formulas that you have in the formula booklet for the area of a sector in radians. So when theta is in radians, the area of the shaded part here will be equal to the area of the sector minus the area of the triangle. So the area of the shaded part will be equal to the area of the sector, which is given by a half theta r squared, because theta is in radians, um, minus a half AB sine theta. AB here represents the radius of the um, the radius of the circle. So basically, if you plug in the radius is 0.5 and AB is 0.5, that will be a half multiplied by theta multiplied by 0.5 squared minus a half multiplied by 0.5 squared um, multiplied by sine theta. So that is the same as 1 over 8 um, theta minus 1 over 8 sine theta. Um, yeah, and that's just the area of the shaded part. So basically the volume um, of the water, so the volume will be equal to the area of the cross section, so area of the shaded part multiplied by the length. So the area of the shaded part um, is this, and the length, so that will be 1 over 8 theta minus 1 over 8 sine theta multiplied by the length, which is 10. So this simplifies to that will be 5 over 4 theta minus 5 over 4 sine theta. So the volume is equals to that. So that's part A. We have the volume in terms of theta. So moving on to part B of this question, what is required is the d theta over dt. And what's given is this, which is dv over dt. So in part B, the given information is dv over dt, which is equal to 0.0008, and then the required information is d theta over dt when theta is equal to pi over 3 or 60 degrees. Okay, so basically we have this. Um, what relationship can we use to be able to analyze this situation? We can apply chain rule. So by chain rule, we know that dv over dt will be equal to dv over d theta multiplied by d theta over dt. Okay, so we can apply this to be able to find what is required, which is d theta over dt, which is here, and using what you're given, which is dv over dt. Now, dv over d theta can be found if we differentiate this with respect to theta and then plug in 60 degrees. So let's do that. So dv over d theta will be equal to 5 over 4 minus 5 over 4 cos theta. But now at theta is equals to 60 degrees, dv over d theta will be equal to 5 over 4 minus 5 over 4 cos 60, which is same as 5 over 4 minus 5 over 4 cos 60 is a half. So that means that dv over d theta will be equal to 5 over 4 minus 5 over 8, which is same as just 5 over 8. Now, we can now plug this information, these two bits, into this equation. So we can say, therefore, dv over dt, which is 0.0008, will be equal to dv over d theta, which is 5 over 8, multiplied by d theta over dt. So that implies that d theta over dt will be equal to 0.0008 multiplied by 8 over 5. And if you plug that in your calculator, that will be equal to 0.00128.